Part A. By writing sec as 1 over cos, show that the derivative with respect to x of sec x is sec x tan x. So, if I write sec as 1 over cos like this, I can differentiate this using the quotient rule, where I say that u is 1 and v is cos x. So therefore u dash would be 0, v dash is minus sine, remembering that the quotient rule is u dash v minus v dash u over v squared, which in this case my u dash is 0, so 0 times cos x minus v dash is the minus sine x times u, which is 1, over v squared, the v is cos. Excuse me. So the 0 times cos x is 0, minus minus, so you get a plus sine x times 1, all over cos x squared, which I'm actually going to write as cos x times cos x. The reason why I'm going to write it like that is that's useful because I've then got the sine x over cos x, which is tan x, and then I've got the 1 over cos x, which is sec x. So we get tan x times sec x, which was what we needed to show. So that's part A of this question. Part B. Given that y equals e to the 2x sec 3x, find dy by dx. So we need to use the product rule because we've got two functions. We've got the e to the 2x and we've got the sec 3x. And we're going to differentiate that using the product rule. So let's let u equal e to the 2x. Let's let v equal sec 3x. So differentiating the exponential gives me the exponential, but by the chain rule I need to multiply by the derivative of the inside, which is 2. Now, differentiating sec. We've just shown in part A of the question that differentiating sec gives sec times tan. So I would have sec 3 theta, tan 3 theta, but by the chain rule, I need to multiply by the derivative of the inside, which is 3. So differentiating sec 3 theta gives sec 3x gives 3 sec 3x tan 3x. Now applying the product rule, which remember is u dash v plus v dash u. So u dash v is this, plus v dash u is that. I don't actually have to with this question. This question just says find dy by dx, so I could just leave my answer like that. But that is a little bit messy here. I don't like the way that's written. So I am going to factorise this a little bit, because I'm probably going to need to for part C anyway. And it's always just good practice to factorise these things. As in, good mathematicians do it, I mean. So I'm going to factorise the e to the power 2x outside. I'm also going to factorise the sec 3x outside as well. That will leave on the inside a 2 plus 3 tan 3x, and that's how I'm going to leave my answer for part B. We're then told that this curve, y equals e to the 2x sec 3x, between minus pi over 6 and plus pi over 6, has a minimum turning point at A, B. finds the constants, the values of the constants a and b, giving them answers to 3 significant figures. So turning point, we know that's where the gradient is equal to 0. So let's take our answer from b that we've written in a nice simple way now and make that equal to 0. Let's look along the line here. E to the power 2x, I know that that cannot equal 0. Remember what the exponential graph looks like? It looks like this. It never equals 0, which is good because it means I don't need to worry about that. Next, the sec 3x. Could that equal 0? Well, remember that sec is the same thing as 1 over cos. And 1 divided by anything, that can never be 0. There's no value that I can divide 1 by that I'll get 0. So that can never equal 0. So that's good because I don't need to worry about that either. The only thing that I need to worry about really is this, the 2 plus 3 tan 3x. When does that equal 0? So let's subtract the 2 from both sides and then divide by 3. So I get tan 3x is equal to minus 2/3. I can then do tan inverse, which will give me minus 0.588. That is in the range that I need here. That is between minus pi over 6 and pi over 6. So that's good. I don't need to draw the graph or find any other values. I can divide both sides by, or I should divide both sides by 3 to get minus 0.196. That's what I meant, was between the minus pi over 6 and the pi over 6. So yep, that is the answer that I needed. All I need now is hit the values of a and b. B is the y coordinate of the turning point. So I need to take my minus 0.196 and substitute that back into the original equation, which was this. So if I do e to the power of 2 times minus 0.91196 times sec, so let me write this out. E to the 2 times minus 0.196 times sec 3 times 0. Obviously, you won't be able to put the sec in your calculator, but you can put 1 over cos. So you would actually type in e to the 2 times minus 0.196 times 1 over cos 3 times minus 0.916. And you should, as your answer, get 0.812. So your A minus 0.196, that's the x coordinate of the turning point, and the y coordinate of the turning point, your B, is that. That's what we needed to show.